Hello everyone. So let us continue our discussion on the design of work surfaces. We have already looked into hand tool and device design. Then we have discussed the concept of anthropometry, and then we have seen what is uh, workspace envelope and different requirements like out of reach requirements, clearance requirements, etc. And now today we will discuss on what is meant by work surface, or rather we will look into the design of work surfaces. So here we will look into horizontal work surface area. So as you see in this figure, it shows the area, different area of reaches for an individual who is working in an horizontal work surface. So if you clearly look this figure, two main areas are of most importance. One, as you can see in the figure, is the normal area, and the other one is the maximum area. So the dimensions given, as you can see here, the top values are in inches and the bottom values are in, or the lower values are in centimeters. So we will now look into what does these two areas, that is, one is maximum area, the other one is normal area. What does they mean, and how are they crucial in the design of horizontal work surface? So normal area means this is the area that can be conveniently reached with the sweep of the forearm, while the upper arm hangs in natural position at the side. So as the name indicates, this is the normal area, or the average area that can be reached by a worker. Whereas the maximum area is the area which you reach by extending the arms from the shoulder. Once you lean forward and extend to the and put your arms to the maximum extent, that is where the maximum area comes. So important thing to note here is two areas, normal area and maximum area. So now we will look into the design of work surface in two different perspective. One is in seated position and other one is in sitting position, standing position, sorry. So in as you know that workers often uh, they assume different positions. Either they can be sitting over a place for longer period of time, or they can be standing and doing some critical jobs. So based on the requirement or the nature of each jobs, the workers will be needed to sit or stand. So we'll look into the design of each of these work surface. In first one, we will look into the seated work surface design. So here, the work surface height is the first priority that we'll be giving, and how it influences the worker performance. So as you know, the height of a work surface can indeed bring on such as aches and pains. If the work surface is too low, you will have to bend over and do the job. And if it is too high, the shoulders must be raised above their relaxed posture. Thus, it can cause shoulder aches or neck discomfort, etc. So, in considering all these factors, two main dimensions or two main aspects are very important in the design of work surface, especially horizontal work surface. One is the work surface height, and the other one is working height. We will look into what is work surface height. So as mentioned in the definition here, it is nothing but the height of the upper surface of a table, or it can be a bench, desk, counter, that is measured from the floor. So in simple words, it is the height from the floor to the top surface of the table that you are using. Now sometimes we will be using slanted work surface or slanted surfaces. Slanted surfaces are nothing but which are having a small inclination and which is flat. In those cases, it is not easy to define the work surface height, or rather it is a little complex. Usually in slanted work surfaces, the height of the front edge from the bottom floor and the angle of the surface will be, angle of inclination will be specified. So in this, and the second aspect, or the working height, is dependent on the worker. So it is nothing but it is what height one is working on. So for example, if you're writing on a paper, the working height is same as the work surface height. So in certain types of task or activities, both this work height and work surface height becomes the same. Now here is a figure which shows two surfaces. One is the horizontal surface, and the B is a special case of horizontal surface, but rather it is known as slanted surface. So what advantages the slanted surface offers is that it will give you better posture, and less trunk movement is required, which can lead to lesser fatigue and lesser discomfort when compared with the horizontal surface. So slanted surface has this ability that it can depending upon the height of the individual, you can adjust the inclination, and so you need to bend less your neck, and you can have a more upright trunk position, less trunk flexion, etc. So obviously slanted work surface has better advantages than horizontal work surface. So you can clearly see that in this image, the arrows are shown, which clearly indicates the advantages a slanted work surface has. Now the challenge here is to how to design this slanted surface, or rather how to keep the materials that are kept on the slanted surface from sliding off the surface. So here is the challenge of the designer. Now coming to the next topic, that is seated work surface height and arm posture. These are two factors that will affect the performance of a user. Working with relaxed upper arms and elbows at 90 degree provides comfort and helps maintaining straight wrist, which can be beneficial while performing repetitive tasks such as typing or electronic assembly, etc. So these points are all self-explanatory, and below is given certain conventional values. Here is another factor, that is thigh clearance. So ANSI, that is Human Factor Society, recommends 26.2 inches as the minimum height for the underside of a non-adjustable seat workers. And if you are having an adjustable seated work surface, it will be better. It will be easy to adjust and use. So the main important thing is that is often that this they usually have to raise their seats so that elbow height is equal to the working height, and often they cannot their feet cannot touch the floor. When though in those cases, it is advisable to give a footrest to support their feet so that they can work more efficiently. So these are all again the recommendations. Now there are certain general principles to be followed for seated work surface. So if possible, the work surface height should be adjustable to fit individual physical dimensions and preferences. So a work surface may be used by different dimensional persons, persons with different body dimensions. For example, there are several computer tables on the market that can easily be adjusted electrically or manually by the use of a crank. So the main highlight here is the user. To make the user comfortable and convenient, yeah, the work surface should be made adjustable. So if that provision is given, it will be very much beneficial for the user. And second point, the work surface should be at a level that uh, places the working height at elbow height. So if you are having your elbow, if you are having the surface equal to that of the elbow height, it will be more efficient for the work for the users, and it will be more easy for the people to work. And third one, the work surface should provide adequate clearance for a person's thigh, that is under thigh, person's thigh under the work surface. So as we have seen in the last slide, the thigh clearance and work surface height is also very important. Now we come to the second aspect, that is work surface height in the case of standing works or standing jobs. Now here the important point is elbow height and the type of work being performed. So in certain kinds of jobs, you will be required to stand all the time and perform the jobs. For example, in the case of a precision work, light work and heavy work are related to elbow height. So in each of these works are of different category. That is, precision work elbow height is not the same as that of the heavy work required. This you can see by looking at the figure in the next slide. So this is a figure showing three different people doing different kinds of jobs. So there is a reference line which is drawn at 0 degree, and this is the zero line, and this is 10 centimeter above it, this is 10 centimeter below, 20 centimeter above it, and 20 centimeter below, and 30 centimeter below. So you based upon this figure, you can see that precision work requires the elbows to be much higher than when compared to heavy work. You can see that precision work, that much concentration is to be given to that work. For example, it can be some kind of jewelry work or goldsmith, etc. So here the work surface table has to be kept at height above that of the elbow height. And for light workers, it should be kept at 0 degree, at 0, that is elbow height. And for heavy works, requires it to be kept below that of the elbow height. Now, balancing anthropometric consideration with user preferences involve compromises, but speaks quite clearly for the height adjustable work surface. So instead of using a fixed surface work surface, if you are having a height adjustable work surface, it will suit all kinds of persons. So that is being explained in this slide. And you have a table here. Table, you have the percentage of the workers who are expressing their interest in keeping it at different levels. That is, for example, for a working on above surface, peeling vegetables, slicing bread, etc. Lower to the elbow, 54 percentage has is okay. Even that is at the same level as that of elbow is 14% and above is 32%. So these are all statistical data based on different experiments.